Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to solve another problem on Laplace transform, and this could be your examination question for your graduate or undergraduate course in mathematics, physics, chemistry and so on. And let's read the statement first. Prove that this limit is equal to this limit, where f, this is little f, is Laplace transform of this capital F, mean big F, right? This is given to you that this little f is a Laplace transform of f, then you have to prove this limit. So let's write the statement again and then plan the strategy. How can we solve it? So solution, limit s approaches to infinity, s into fs equal limit t approaches to 0 plus f of t. 0 plus mean value of t is very much close to 0, and whatever that value is, that is a positive number. Okay. Now, you have been told that this f is a Laplace transform of f. Write this here. So that whenever you are sticking to the statement, then your problem will be solved accordingly and easily. The problem solution of the problem will be an easy going. That's why f is a Laplace transform of f. Write this thing here, f. This is Laplace transform of f, capital F. Right? Laplace transform is an integral operator and its action on the function is represented by the curly bracket. This you already know. Okay. Next, right hand side is same, no change. Now, what next we should do? This is the general formula for the function. If it were sine, then we know the Laplace transform of sine function. If it was exponential, then we know the Laplace transform of the exponential. But this is a general function, neither exponential nor sinusoidal and so on. So what should we do? We have made a video on the Laplace transform of t to the power n, right? Keeping that in view, you may think that ft, any function, can be expanded in the form of Maclaurin series. And Maclaurin series is a power series in t, mean it contains exponents of t, mean powers to t to the power 0, t to the power 1, t to the power 2, t to the power 3 and so on and so forth. And when it comes t to the power 1, 2, 3, then we can find Laplace transform of t to the power 1 and t to the power 2 and so on and so forth by using the formula of Laplace transform of t to the power n. Right? When we know this or have a planning in our mind, then we should plan that ft should be expanded in the form of Maclaurin series. Let's write that series and name this equation for the time being here as 1. And accordingly, the Maclaurin series of ft about t equal to 0 is, that formula is ft equal f0 plus t into partial ft by partial t evaluated at t equal to 0 plus t square over 2 factorial and partial 2f t by partial t square evaluated at t equal to 0 and plus so on, dot dot dot. Now f0 is value of the function at t equal to 0, and whenever you evaluate a function, mean find value of the function at one specific value of the variable, it is always a constant, and you can name this constant as a naught to keep the things simple. Similarly, this t and this is value, this is the derivative with respect to t, and when you will evaluate this function at t equal to 0, you will get another constant, and let that constant is a1 plus this is t square into, this is the second derivative, and it will be some function, and when you will evaluate this function at t equal to 0, then it will be a constant, and this constant divided by 2 factorial will be another constant, and you may name it as a2 and plus dot dot dot, right? So in this notation, apply the sign, this sign. Okay, in this notation you can see that this is the power series, and a naught, a1, a2 are the constants. Okay, now use this series here. Remember, this is f naught and this is a1, and this 2 factorial and this is square root, this is a2, and so on. So let us substitute it, means sub it in equation 1. Let's do the substitution in equation 1 this, and let me do it on the other board. Yes, I write it here. Limit s approaches to infinity, s into, this is the Laplace transform operator, write it, and then curly bracket, and ft should be this power series, a naught plus a1 into t plus a2 into t square plus dot dot dot, means so on, right? This t into a1 can be written a1 first and t later, a2 first and t square later. Okay, bracket closed, and it is equal to limit t approaches to 0 plus, and next you have ft, and in place of ft you may substitute this series. Okay, so the series again, a naught plus a1 t plus a2 into t square and plus dot dot dot, means so on, right? Now you know this Laplace transform is a linear operator, and using its linearity we can simplify this. And what is the linearity property? This operator will act on the function, and the constant will be written in front of the operator L, mean on the left of the operator L. So let's use, using linearity of L, what you get? Limit s approaches to infinity, s into this. Laplace a naught is a constant, it will be taken in front of this, and you will be left with Laplace transform of 1, because if nothing is here, there will be 1, right? This constant can be taken out and you will have Laplace transform of 1, plus a1 is a constant, it is written in front of the operator L, mean on the left of operator L, and it will act on the function only, and the function is t here. Next, plus a2, this is the constant and will be written in front of the operator L, mean on the left of the operator L, and this operator L will act on the function, and this time function is t square, and plus dot dot dot, bracket close, and equal to, what's on the right hand side? You can apply this limit here, a naught plus a1 into 0 plus a2 into 0 square and plus dot dot dot, right? We have applied the limit. Now you know the Laplace transforms of these functions. Using Laplace transform of t to the power n is equal to gamma of n plus 1 over s to the power n plus 1, and condition for this is s is greater than 0 and n is greater than minus 1. Now use this formula here. Limit s approaches to infinity as such, a naught. You have a 1, Laplace transform of 1. By the way, this you already know, Laplace transform of 1 is 1 over s. And if you do not remember it, you can also find it from here. 1 means t to the power 0, so n is 0, and you will have the Laplace transform as gamma 1 means 0 plus 1 over s to the power 0 plus 1, right? When n is 0, t to the power 0 is 1, so Laplace transform of 1 is this, and the answer is this, which you need to write in the next step here. So 0 plus 1, I have written explicitly 0 plus 1. Okay, next you have a1 this, and you need Laplace transform of t to the power. If there is no exponent, it is 1. It means your n is 1, and n1 means your answer for this is here gamma 1 plus 1 over s 1 plus 1, right? And plus a2 into Laplace transform of t square, that means n is now 2, and when n is 2, your answer is here gamma of 2 plus 1 divided by s to the exponent 2 plus 1, and plus dot 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 bracket closed, and here you have a naught, and this is 0, this is 0, and you do not write 0. So on the right hand side your answer is a naught. Now on the left hand side what you have, limit s approaches to infinity, and there is s into, this is a naught into gamma 1 divided by s plus a1 into gamma 2 over s square, a2 into gamma 3 over s cube, and plus dot dot dot, right? And it is a naught on the right hand side. Now you can multiply this s inside. Let's do this multiplication. Limit s approaches to infinity. This is a naught into gamma 1 plus, this s has been cancelled. When this s is multiplied here, you will have a1 into gamma 2 over s. One exponent of s will be cancelled. Plus a2 into gamma 3 over s square, and plus dot dot dot, and bracket closed, a naught, right? And when you apply this limit, the divided by infinity, this is a finite number, this is a finite number, and finite number divided by infinity produces 0. This is also a finite number, divided by infinity square is infinity, that means 0, and so on. Okay, so when you use this limit, let us use here. What are you getting? The first value, a naught into gamma 1 is 1. This is a naught, and this is gamma 1 is 1, and plus this is 0, because divided by infinity, finite number, a1 is finite, gamma 2 is finite, divided by infinity means 0. You are applying the limit. Okay, plus 0, and the next will also be 0, because you have again a2 and gamma 3, these are finite numbers, divided by infinity will be 0, and plus so on, every term is 0, and plus so on, and it is equal to a naught. So look, you can also make a reference, because gamma 1 is equal to 1. So this implies a naught is equal to a naught. This means given equation is an identity. Identity means whatever is left on the right, that is different in shape, but in effect its value is the same as the value on right hand side. So the given equation is correct. This means given equation is an identity. that is limit identity. Hence, to make a assertive and final announcement, hence limit s into fs and s approaching to infinity is equal to limit of the function ft when t approaches to 0 plus. So this was your question, which has been proved that left hand side has answer a naught, right hand side has also answer a naught, mean these two are same. Okay, so this is your final answer. I hope you understand. This is not important how many questions you are going to solve. This is important you are learning the strategy or not. Learning the strategies is important, and it is the objective of this channel to make you not impress through the solutions by whatever method. The purpose of this channel is to prepare you for the planning of strategies which are usable in solutions of the problems in mathematical physics, or in the problems of physics, or in the problems of physical chemistry, or in the engineering problems. So keep watching, and please like, share and subscribe this channel with your friends and family, so that such strategical solutions comes to you in the first place. Thanks for watching.